Today the topic for discussion is bisection method. So again, this method is useful to find the root of the algebraic equation and transcendental equation, like Newton-Raphson method. So what is the given equation? Suppose fx is equal to 0 is the given equation, okay, and you have to find the approximate real root of this equation fx is equal to 0. This equation is either transcendental or algebraic equation. So first find two numbers. Real numbers a and b. Obviously, instead of real numbers, you can find two successive integers a and b, such that for this a and b, f of x is negative and positive. That is, f of a into f of b is less than 0. So when this multiplication is less than 0, if one number is negative and one number is positive. Otherwise, this is not less than 0. If both are negative, f of a and f of b, then multiplication is positive. And if both are positive, then also the multiplication is positive. So when this f of a into f of b is less than 0, if one of them is negative and other is not positive. Okay. So first find two successive integers. Suppose instead of these real numbers, you can find successive integers. What are the successive integers? 0 and 1 are successive integers. Minus 1 and 0 are successive integers. Minus 2 and minus 1 are successive integers. So first find two integers a and b, such that f of a and f of b has opposite signs. Okay, and then use this formula. xr is equal to a plus b by 2. R runs from 0, 1, 2, 3 up to infinity. Okay. In Newton-Raphson, this formula is what? xr plus 1 is equal to xr, or instead of r, if there is notation I, then xi plus 1 is equal to xi minus f of xi divided by f dash xi. This is the formula in Newton-Raphson method. So instead of that, use this formula xr. What are a and b? A and b are these two numbers having a negative sign, opposite signs. And then if this f of xr, that is by using substituting r is equal to 0, what do we get? x1. What is x1? x0. So instead of this r is equal to 0, 1, 2, 3, okay, we can replace r is equal to 1, 2, 3, 4, 5. So if we replace r is equal to 1, then x1 is what? A plus b by 2. This is the first approximation. A plus b by 2. And if this f of x1 is 0, if f of x1 is 0, then x1 is the exact root of the given equation fx is equal to 0. If the f of x1 is not equal to 0, then what is the procedure? Find the sign of the fx at x1. So if the sign is negative, then the root lies between a and x1, and perform the second iteration x2, that a plus x1, that is call this x1 as b if the sign is negative, and then perform the second iteration, that is find x2 by using the formula a plus b by 2. What is b? B is x1. And if this at this x1 fx is positive, then root lies between x1 and b. Then call this a1 x1 as a, small a, and then again perform the second iteration, that is find x2 by using the formula a plus b by 2. And what is a? A is x1. Okay, so we get x2. Then after second iteration, we get x2. That is the second approximation. Okay, so repeat this procedure for next 3, r is equal to 3, r is equal to 4, r is equal to 5. That is find x3, x4, x5, and so on. And stop when you get a desired accuracy. So the problem on the method, So what is the problem? Find a positive real root of equation x is equal to e raised to minus x, which lies between 0 and 1. So here we are given a and b. What are a and b? 0 and 1. If we observe, this is fx. What is fx? So this e raised to minus x shifted to LHS, so it becomes e raised to x. And so x into e raised to x is equal to 1. That is x e raised to x minus 1 is equal to 0. Instead of this, we can also take x minus e raised to minus x is equal to 0. That is the equation fx. Okay. Then if we observe the value of this fx, this is fx, then at 0 it is minus 1, and at 1 it is the 1.718. Okay, and so at 0 the value is negative, and at 1 the value is positive. Okay, and therefore the root lies between 0 and 1. So take a as 0 and b as 1, and then what we have? X1, that is the first approximation, a plus b by 2, by using the formula of bisection method, we get the value 0.5. That is the midpoint of this a and b. Okay, 0 and 1. 0 and 1. At 0, the value is negative, and at 1, the value is positive. And this is the x1, 0.5. Then find the value of fx at 0.5. That is, find f of 0.5. So what is f of 0.5? It is minus. So you can find f of 0.5, substitute in this fx, x is equal to 0.5. So by using this is fx. X into e raised to x minus 1 is fx. So f of 0.5 is this, negative. So here at 0.5 the value is negative. So at 0 value is negative, at 0.5 value is negative, and at 1 the value is positive. And therefore root lies between 0.5 and 1. And then this is now a, and this is b. Okay, 0.5 is a and 1 is b. And then x2 is what? The next approximation is what? The value, the root lies between 0.5 and 1. Here the sentence is what? As the value at 0.5 is negative of fx, and the value at 1 is positive, and therefore root lies between 0.5 and 1. Okay, and then take this as a and this is as b, and then use the formula x2 is equal to a plus b by 2. That is this 0.5 plus 1 divided by 2. And that we have the answer 0.75. Again, find the value of fx at 0.75. That is f of 0.75 by using this formula. Fx is equal to x e raised to x minus 1. And we get the value 0.5877. That is, we get the value positive at 0.75. Fx is what? Positive. And so the root lies between 0.5 and 0.75. And then find x3. What is x3 then? 0.5 plus 0.75 divided by 2. That is the midpoint of this interval, 0.5 to 0.75. This is the, at this place we have x3. Then again find the, if you have to find x4, then again find the value at 7, at this 0.5625. Okay. So what is the difference between these two, x1 and x2, x2 and x3, x2 and x3? x2 is what? 0.5877, and x3 is what? 0.5625. And so this answer is correct up to 1 decimal places, because if we subtract, if we find subtraction of this x2 and x3, then it is equal to not something. Okay, and that is, this answer is correct up to 1 decimal places. And so we declare that 0.5625 is an approximate root. If your question is find a positive real root up to 3 decimal places, 2 decimal places, then we find next further approximation, that is find x4, x5 by using the same method. Next problem. This is the previous one is what? Previous one is what? Transcendental equation, but this is the algebraic equation. So x cube minus 9x plus 1 is equal to 0. And we have to find the real root of this equation. Obviously, we have approximate real root of this equation. The degree of this equation is 3. Therefore, this equation has total 3 roots, and we have to find only one root out of that 3 roots. Which lies between 2 and 4. This is the instruction. That is, root lies between 2 and 4. So take 2 and 4 as a and B. Okay, and then find x1. So what is x1? 2 plus 4 by 2. That is 3 is the x1. And if you find the value of this fx at 2, then it is negative, and value at 4 is positive. And therefore, the root lies between 2 and 4. There is given why root lies between 2 and 4, because at 2 the value is negative and of fx, and at 4 the value of fx is what? Positive. And therefore, here we have f of 2 into f of 4 is obviously less than 0, because one number is positive, one number is negative, their multiplication is negative. So by root notation root theorem, the root lies between 2 and 4. Okay? So a is 2, suppose b is 4. Here in diagram, what is 2? At 2, what is value of fx is negative, and at 4 the value is positive. And therefore, x1 is what? A plus b by 2. A plus b by 2. And the value of at the value, so x1 is 3. This is the first approximation. And at 3, the value is what? At 3, the value is what? Value of fx is what? Positive. And therefore, the root lies between. Here we observe the value at 2 is negative, value at 4 is positive, and the value at 3 is positive, and therefore root lies between 2 and 3. Because at 3 value is plus, at 4 the value is also plus, and so there is no root lies between plus and plus. When we say the root lies between the two numbers, if their signs are opposite. So at 2 and 3, the signs are opposite, and therefore the root lies between 2 and 3. Okay, and so the next x2 is what? 2 plus 3 by 2 plus 3 by 2, and is again 2.5. Okay, and this is the second application. Then I can find the value at 2.5 of fx. So at 2.5, fx is negative, is minus. Therefore, at 2 value is negative, at 2.5 value is negative, and so there is no root lies between 2 and 2.5. So at 2.5 value is negative, at 3 value is positive, and therefore root lies between 2.5 and 3. And so the next approximation is what? x3, 2.5 plus 3 by 2, that is 2.75. In this way, I can find the value at 2.75. If it is plus, then root lies between 2.5 and 2.75. If it is negative, then root lies between 2.75 and 3. And then add these two numbers and divide by 2. We get x4. Similarly, find x5. And if you observe these two answers, these are not correct up to 1 decimal places. So we can continue the process or declare that this is the approximate root of the given equation. Okay. So next problem again is the transcendental equation. Find real root, correct up to 3 decimal places. Okay, that is the subtraction of two successive approximations is what? Point not something, 3 times not and something. Okay, so this is the equation, and the root lies between what? 0.5 and 1. So take a as a 0.5 and b as a 1. If these numbers are not given in the problem, then we find these numbers by using trial and error method. That is the find the value of fx at 0, at 1, at 2, at 3, and if all the signs of the numbers fx are same, then search these numbers to left of 0, that is at -1, at -2, at -3, and find two successive integers such that f of x is negative for one number and positive for another. Okay, that is the value of fx at that points are having opposite signs. Okay, So fx is, this is the given equation. So here the numbers are given. Therefore, x1 is what? Is 0.5 plus 1 divided by 2. And at 0.5, the value is negative, and at 1, the value is positive. Therefore, their midpoint is the next approximation. Bisection. Why is called bisection method? Because it's bisect the line. It divides each time. It divides the line, the interval in two equal parts. Okay, and then x1 is what? 0.75. Okay, so find the value at 0.75. Here is the chart is given. So at 0.75, what is the value? Value is positive. Value is positive, and therefore root lies between 0.5 and 0.75. And so take A as a 0.5, B as a 0.75. Here, the first is what? 0.5 and 1 are the A and B. And at 0.75 value is positive. Therefore, 0.5 and 0.75 becomes, and therefore the root lies between what? 0.5 and 0.75. And therefore, the next approximation is what? 0.5 plus 0.75 divided by 2. That is this answer, 0.625. This is the answer. And at this point, the value is what? The value is positive at 0.625. So this is the 0.625. The value is what? Positive. And therefore, the root lies between 0.5 and 0.625. And therefore, 0.5 and 0.625 are 0.5 and 0.625 are what? Are A and B. 0.5 and 0.625 are A and B. And therefore, their addition divided by 2 is what? The next approximation. Again, find the value at this point. And perform the next iterations. Here is the next iterations. And if we observe these two answers, last two answers, value of x, here is 0.55 and here is 0.550. And if we subtract these two answers, then we have the answer point not something. And therefore, this answer is correct up to, actually this answer is correct up to 2 decimal places, because we have the answer point not something. And we write last sentence that the root of the given equation, approximate root of the given equation is 0.5501. Okay. Similarly, the next problem using bisection method. This is fx. Then find by using trial and error method, find two numbers such that this fx is what? Is negative and positive at that time. And data numbers are 4 and 5. At 4, the number is negative, and at 5, the number is positive, and therefore root lies between 4 and 5. Okay, and therefore the next approximation, either write x0 or x1. What is x1? 4 plus 5 by 2. That is 4.5. And again, find the value of 4.5. At the 4.5 value is positive, and therefore root lies between 4 and 4.5. So the next is what? x2 or x1. So if what is it? 4 plus 4.5 by 2. And perform in this way. Here is the next 12 iterations. After 12 iterations, what we get? The answer correct up to 3 decimal places. That is, if we substitute these two values, we get the answer point not 3 times not something. Okay, and so write the last sentence that this is equal to 4.3046 is the approximate root of the given equation. So these are some exercise. These are all our algebraic equations. Their answers are in bracket. So these two are what? These two are transcendental equations, and their answers are given here. 1.113, and this is the answer of this problem. So stop here.